Quantum Laser Pointers brings you the infamous double-slit experiment right in the palm of your hand. In 1801, English physicist Thomas Young performed this experiment to determine if light was a particle or a wave. A laser shines a coherent beam of light through a film disc containing two parallel slits. Light striking the wall behind the slits produces a classic interference pattern. This surprising result means light passes through the parallel slits not as particles, but as waves.
Visit our website or subscribe to our YouTube channel now. Be among the first to see our new line of double-slit lasers, quantumlaserpointers.com.
My name is Anton Zeilinger. I'm a professor of physics at the University of Vienna in Austria. For some reason I was always curious about things. Like when I was a little boy, I liked to take apart things. I was usually not able to put them back together again, but I took them apart. Like, for example, I took the legs and the arms off the dolls of my sister, which she certainly didn't like. So I just wanted to know how this works, how this mechanism works. And this is as far back as I can think. So when I went to school then, I had the big luck to have an excellent teacher in physics. You know, even in things which in other schools might be boring, he was able to present in an interesting way. And certainly, I mean, the most interesting situation was when he started to talk about the theory of relativity of Albert Einstein, you know. And there he gave me, and not only me, a couple of others in my class also, he gave us the feeling that we understand what's going on, which I now know is not true, but it was exciting and it was important for us and it provided a big motivation. And we learned, basically, you can find out if you want. And that's a very important message. My father was a scientist. He was a chemistry, so he was a professor himself. So I must have gotten it both through the genes and through the environment. Simply that, you know, sometimes I visited him in his lab. I didn't understand what was going on, but just the atmosphere was probably important for me. He worked on what we would today call microbiology and genetics. So it was the questions how bacteria multiply, how they modify over the life cycles and things like that. Initially related to, interestingly, dairy industry, how to make milk and cheese and so on. This was the starting point for him, but it went much deeper than that. I never considered a career along that path, and I don't know why. It was probably the very fundamental questions which you meet in physics, which interested me. Chemistry, or at some point I thought briefly maybe I would study medicine to become a scientist there. There's lots of interesting science in medicine. But I quickly found out that the fundamental questions are more interesting for me personally. That's just the feeling, you know. I have 3 children who are grown up. And one is an artist, another one studied law, and the third one is interested in urban planning. Very different from science. If they would have been interested, I would have provided some encouragement. But the first decision has to come from the young person themselves. You know, we should not push young people in a direction where they don't want to go on their own already, in a sense. If I would give one advice to young people, and that is if you find something interesting, go for it. It doesn't matter what it is. If you really find it interesting, you will make your way and you will find it interesting. And if it happens to be science, I can guarantee that you will lead a very interesting life. I'm really interested in sailing. I love to sail because this is a very interesting activity. It kind of keeps you busy all the time. And this is one of the few situations where I don't think about physics because you are so busy in doing other things. So I love sailing, and I like music. I like jazz. I don't like modern jazz so much. I like more classical versions of jazz. I played the cello, and I also started to play some bass, but that is now already 20 years ago. I should pick it up again, I know, and I will, there's no question. Many physicists are interested in music. And once I heard that there's a relationship in terms of brain activity, that if you listen to music, if you are fully immersed in music, then many parts of your brain are active. And that seems to be the case also when you are creative. As a scientist or as an artist, that doesn't seem to matter. It's quite interesting, actually. There's a lot of parallel, by the way, between art and science in terms of the creative process, in terms of finding new ways where you don't exactly know which way to go, where you have to have a hunch, you have to have a feeling, and so on. You know, the really, really interesting new steps are steps where your feeling is important. It is quite exciting to find something out as the first one, or the group. In physics we work in groups with people, you know, few young people around me, and in a group all this give and take and this discussion all the time. How could it be? How could we improve things? How could we find out, and so on? That is really exciting. It's never about making money. That's an important point. It's never about making a big career. It's just curiosity. Well, I became interested in quantum physics towards the end of my university education. When we learned quantum physics, which is a very mathematical and very abstract body of knowledge, I was fascinated by the mathematical beauty. That is actually something which if you really see how beautiful some of the mathematics is, it's mind-boggling. It's impressive. And secondly, I realized that the deep conceptual questions, what does it mean for the world, what does it mean for our understanding of the world, they were not answered, they were open. So I got excited by that. I wanted to find out, and it's fascinating. Quantum physics has been invented in the beginning of the last century, and it was invented to explain the behavior of atoms and small particles and so on. And very soon people found out that these particles are in a very fundamental way different from what we see in everyday life. So there are things like what you observe depends on whether you look at it or not. The observer is very important. Or there is something which Einstein called spooky action at a distance. If you do some measurement here, it influences instantly the state of affairs at some other location far away. Well, the big point is we can do now experiments in a way the creators of quantum physics would not even dream of. So we can see all these phenomena very detailed in experiment. We can ask new questions about what is reality, things like that. And we can also develop new ideas about our role, about the role of information, about the role of knowledge and so on. So we have learned a lot in doing these things. We have learned to ask deeper questions, but the final conceptual questions are not completely answered yet. These are questions like, what is really real?
Of light through a film disc containing two parallel slits. Light striking the wall behind the slits produces a classic interference pattern. This surprising result means light passes through the parallel slits not as particles, but as waves. Quantum laser pointers brings you the infamous double-slit experiment right in the palm of your hand. In 1801, English physicist Thomas Young performed this experiment to determine if light was a particle or a wave. A laser shines a coherent beam.
I like to take apart things. I was usually not able to put them back together again, but I took them apart. Like, for example, I took the legs and the arms of the dolls of my sister, which is physics at the University of Vienna in Austria. For some reason, I was always curious about things. Like when I was a little boy.
Visit our website or subscribe to our YouTube channel now. Be among the first to see our new line of double-slit lasers. QuantumLaserPointers.com.
My name is Anton Zeilinger. I am a professor